All right, guys, we're going to start chapter 6. Now, 6.1 here, I want to tell you this straight off the bat. This is a review. Okay, we should have started doing systems in 8th or 9th grade there. So I will tell you this, that there is no homework that you have to do with 6.1. Now you can double check. I just checked. I'm pretty sure there is no computer homework. So either you can go through the whole lesson as just a reminder on how to solve linear systems and everything like that, or if you want, you feel confident, you can stop right now and move on. Okay, I'm going to do this lesson as a reminder of how to solve systems of linear and nonlinear equations. Okay, so we have a couple ways that we can do this. This is a 2x2 right here. So what that means is we have two equations and we have two variables. Okay, so this wants you to solve it by substitution. So what we could do is rearrange one of the equations, and I'm going to rearrange the one down below. Does it always have to be the one down below? No, you really do want to analyze and say which one looks more simple to solve. Okay, so of course I just moved this 4x over. Now that I do that, I'm going to substitute this, and for every y I see into the equation I did not manipulate. So 2x, now this is where most people mess up, minus parentheses 4x minus 5. We're subtracting the y, and the whole y is 4x minus 5. So we have to subtract the whole thing, that's in parentheses, and then we solve. So we get 2x minus 4x plus 5 equals 1. I'm going to continue my work over here, guys. So that gives me negative 2x. I'm going to move that 5 over, equals negative 4. Divide both sides, we get x equals 2. Now, when we do systems of equations and everything, we want to make sure that we are solving for all of the variables. So this is just x. To find y, we plug back in. We should be able to plug into either one of these equations and get the same value of y. So if you're nervous about your calculations, you can always substitute into both equations and hopefully you get out with the same y. For me, I want to say, let me substitute in the x to the easiest one. So negative 4 times 2 plus y equals negative 5. Negative 8 plus y equals negative 5. So y equals 3. Now, when we write coordinate pairs, and this time it's paired because it's a 2x2. We're going to get into other ones in this chapter where we have more. Usually your coordinates go in alphabetical order, so this answer would be 2, 3. Now, that was one way we learned how to do it algebraically. This way we're going to do some elimination here. So when I look at this 2x2 system, I see that my x's are opposite of each other. Well, to eliminate, to get rid of, if we had two numbers that were total opposites, to get rid of it, we would add them. We would add straight down because 3x plus negative 3x is 0. Now, if they were the same, if it was 3x and 3x, we would subtract, okay? Because the idea is to get rid of it. So we're going to add straight down in this case. These cancel. 4 plus negative 1 is 3y. And negative 2 plus 5 is 3. So y equals 1. Again, to find the x value, we can substitute into either equation. I'm going to substitute into the first one. Another mistake a lot of people make is they forget what variable they actually solved with to begin with to substitute back in. So as you can see, it was a y. I made sure to put it in the y place. So we get 3x plus 4 equals -2. 3x equals -6. So x equals -2. Remember, coordinate pair, alphabetical order. So -2, 1. Okay. In B, if we look at B right away, because this is elimination, I should be able to add or subtract straight down. But as you can see, our x's and y's don't equal each other. So what can I do? Well, what I have to do is I have to multiply the equations to be able to have them match. So I'm going to multiply the top equation by 3, the bottom equation by 2, so I can get the x's to be the same. Now, we could have done that for the y's. And in this case, I might have said, let's multiply 6 in the top, 4 at the bottom. That depends on you. All right, so remember when we multiply, we have to multiply all the terms. So 3 times 2x is 6x. -4y times 3 is -12y. And 6 times 3 is 18. That right-hand side is where most people forget to multiply, so don't forget that. 3x times 2 is 6x. -6y times 2 is -12y. And 9 times 2 is 18. Now, I'm going to focus on my x. I mean, it might be obvious right now, and you're saying, Ms. Heckman, those are the two same equations. But let's just say I didn't see it, and I'm continuing. I see my x's are the same, so I'm going to subtract straight down. Well, that gives me 0 on this side equals 0 on this side. Okay, if the variables eliminate, we have to say if it's a true statement or not. Does 0 equal 0? Yes, it does. It's a true statement. So since this can happen, we have infinitely many. Okay. If our variables disappeared, both of them, and we got something that was untrue, like -5, then it would be no solution. And what do you know? On the next page, this example will probably give us no solution. So again, we have 6 and 4 here. You can do your x's. I'm actually going to do my y's this time so you guys can see the difference. I'm going to multiply the top by 2, the bottom by 3. I get 12x plus 6y equals 18. On the bottom, I get 12x plus 6y equals 36. Now they are the same value of x's. Sorry guys, I had a coughing spell. Didn't think you wanted to see that. So again, the x's are the same, so same means that I subtract straight down. Well, on this side, this whole side cancels to 0. But when I subtract straight down here, I get -18. Does 0 equal -18? No, they don't equal. So that means it's no solution. Hopefully this is coming back to you guys. All right, let's talk about some more vocab words, and we're going to continue. If a system of equations, linear or nonlinear, has no solution, okay, this is where it becomes more important. But I will actually go over this again in case people aren't watching the whole video. So if it has no solutions, it is called inconsistent. Okay. If it has at least one solution, it is consistent. In the case of linear systems, we can divide the consistent systems into 2 categories. Okay? So consistent can have 2 categories. We have a consistent linear system is called independent if it has a single solution. Geometrically, this solution is a point at which the intersection of 2 lines has different slopes. A consistent linear equation is called dependent if we have an infinite number of solutions. So in other words, for linear, it's going to be where they're the same slope, they're parallel, okay? All right, now let's move on to some practice with nonlinear. What happens here? Now, as you can see, the example doesn't say use elimination or substitution. But I will tell you with nonlinear, it's actually easier if you do substitution, but I'm going to do it with both, okay? I'm going to show you what that looks like. So in A, first of all, I want you to picture what could happen. If you see, because we have ones in front of the x squared and y squared here, and it equals the value of 4, we know this is a circle, okay? And because we have this, if I divide by 4, divide by 9, we would actually get 1 here, and we would have fractions where the a and b are different. This is addition, so this is an ellipse. So you could actually picture a circle and an ellipse and see how many times they would be able to intersect, if they intersect at all. So in this case for A, I'm going to use substitution. And I'm using it right now. I can use elimination, but I'm going to use substitution just so you can see. So I'm going to solve for x squared. Now, I don't have to solve for x, guys, because when I'm replacing, there we go. When I'm replacing, I'm going to replace the x squared anyway, so I don't need to worry about it. So I subtracted the y squared from both sides. I get negative y squared plus 4. Then I'm going to substitute this in for every x squared, right? So 4 times, instead of x squared, I'm going to put the negative y squared plus 4 plus 9y squared equals 36. I'm going to start solving. Negative 4y squared plus 16 plus 9y squared equals 36. Let's see, that leaves me with 5y squared equals 20. Divide by 5, we get y squared equals 4. Now remember, we're doing coordinates, so we need x comma y. So we do have to take the square root of both sides. But be careful, because when we take the square root, how many answers do we actually get? So y equals 2, but it also equals negative 2, okay? So that means I have 2 coordinates in which I have to plug into both, or plug in both the separate times to find that x value, okay? So when I plug in 2, oops, and this is going to be the y value, right? When I plug in 2, the y on top, I get 4, and I move it over, I get x squared equals 0, so x equals 0. Well, what do you know? That happens the same thing as if I plug in negative 2 for y. Negative 2 squared is 4. Move that 4 over, we get 0. X squared equals 0, so x equals 0. And there are 2 solutions. For B here, I'm going to use elimination this time. But I want you to see that the top one is a circle and the bottom one is a hyperbola. Okay, think of it. So we have a circle and we have a hyperbola. And I say it like this because it's a horizontal since x is first. How many ways can we intersect? Well, technically, we could probably get up to 4 ways, right? If we had a huge enough circle and the hyperbola went into both, right? We could have tons of ways. So we'll see what happens. This time, like I said, I'm going to eliminate. So I need to get the first equation to have something the same as the second. So what I'm going to do is multiply the first equation by 4. I'm going to rewrite everything down below here so we leave myself room. 4x squared plus 4y squared equals 16. Don't forget to multiply that right side. I'm actually going to keep that hyperbola the same since I'm making the top look like the bottom. Now, since they are the same, I'm going to subtract straight down. So the 4's cancel. 4 minus negative 9 is 13 y squared. And 16 minus 36 is negative 20. Okay, let's solve. We get y squared equals negative 20 all over 13. Take the square root of both sides. What do you guys notice? Can we take the square root of a negative number? No, it's not possible. So this is no solution. So in here, when it comes to nonlinear, it's not that the variables necessarily cancel out, but we come to a false statement, okay? Something that cannot happen. All right, so let's continue again if you want more practice. Okay, because now we're going to get into just a little bit. Let's see, we have a circle here, right? And because x and y are to the first here, this is linear. In this case, it might be easier just to do substitution, right? So I'm going, which one looks like the easiest to rearrange? Well, the bottom one. So I get y equals 2x. I'm going to substitute that in. So x squared plus, instead of y, I'm going to put 2x squared equals 5. That's x squared plus 4x squared equals 5. 5x squared equals 5. X squared equals 1. And then x equals plus or minus 1. All right, so now we have to plug back in. So let's plug in negative 1 here. Okay, we'll plug in 1 on this side. Okay, so we get 1 plus plus y squared equals 5. Y squared equals 4. So y equals plus or minus 2. And then we have 1 plus y squared equals 5. Y squared equals 4. Y equals plus or minus 2. All right, so if we put these together right here, I get negative 1 comma 2 and negative 1 comma negative 2. All right, we get 1 comma 2 and 1 comma negative 2. Has anyone recognized the problem we're running into right now? Think of this. This is why I like you guys picturing what the shape is beforehand. Because a circle and a line, will it ever be able to intersect at 4 points? No, it won't. So there's an issue here. So what we have to do is we have to substitute back in to make sure we're making a true statement, okay? So 2, if I plug in 2 for y and negative 1 for x, what happens? Wait a second. That would be 2 plus 2. 2 plus 2 does not equal 0. So that point does not work. See how it has to work for both? We can check that here. Negative 2 plus 2 is 0. So we're good here. 2 minus 2 is 0. We're good there. Negative 2 minus 2. That doesn't work. So our two answers, or 2 coins, are these two. Okay. Oh, this one gets a little bit algebraically crazy, huh? Let's see. And this one, if I look at it, this one's really going to be hard to manipulate down below. Adding and subtracting straight down, that doesn't look good. So I guess my only option is to rearrange this top one. So if I rearrange this, what's the easiest variable to solve for? Y, right? Because it's by itself. So I get y equals negative x squared minus x. No, I don't. Sorry, this would be negative y equals all of that. We'll multiply everything by a negative. I get y equals x squared plus x. I guess you could have just moved the y over and that would have been easy, right? Now I'm going to substitute. So you get x squared plus x, and that squared, that's taking over that y squared over here, minus parentheses x squared plus x plus 1 equals 0. I know this looks like a lot, but really it's about the algebra. Here, what I'm going to do is factor that out. Not factor, FOIL it out. Some of you who don't know what I mean by FOIL, maybe do the box where you go x squared plus x times x squared plus x. Okay, I'm going to do that in my head. I get x to the 4th plus 2x cubed plus x squared all over x. Okay, I'm going to keep this in parentheses at the moment. Now, I will tell you this, one move I am going to make right now. No, I'm not going to make it. I'll show you why. Okay, what I do want to show you is that they all have the same term right here. So what I can do is divide each term by that denominator. So what happens here is x to the 4th divided by x is x cubed plus 2x cubed divided by x is 2x squared. X squared divided by x is x. And then I have minus. Now I'm going to keep this in parentheses. X squared divided by x is x. Plus x divided by x is 1. Equals 0. Okay. Now let's distribute that. X cubed plus 2x squared plus x. That's going to be minus x minus 1 plus 1. Woo! Tons of algebra, guys. Okay, so the ones cancel. The x's cancel. I get x cubed plus 2x squared equals 0. So now I can factor. X squared comes out. X plus 2 is left. What makes this 0? Well, down here, x equals 0. What makes this 0? X equals negative 2. All right, so now if we plug back into the top, you find that if x is 0, y must be 0. And if x is negative 2, you can do that algebra, and we get y equals 2. Now, we have no idea on the other one, like the other one, how this graph is pictured. So we should check our points anyways. And you can check down below. Well, here's an issue. You guys see 0, 0? You cannot divide by 0. So right away, this is not a coordinate. But if we find when we plug in negative 2 for x and 2 for y, we find that it does work. So you guys, I know you're terrible at this, but check your work. All right, let's go on one more, right? And then I can go on to 6.2. All right, more algebra. All right, what looks a little bit better to do? They both have x and y's, and I'm a little concerned about that xy. Here's the tricky part. If you look at this top, you are able to factor that. Okay, so let's say, pretend it was x squared minus 3x plus 2. You guys can factor that, right? That would be x minus 2 times x minus 1. Now, did you guys see how I left a little space for the parentheses? It's because we're missing a y squared here and a y here. How can we get y squared? Well, y times y. Okay, so we were able to factor that. Now, what happens here is I'm going to solve for a variable here and solve for a variable here. Okay, so I get x minus 2y equals 0. So x equals 2y. Where here we have x minus y equals 0. So x equals y, which means we have to test both cases. So here I'm going to test that in the one down below. I am going to put that x is 2y. So 2y squared plus 2y times y equals 6. So that's one case. And down here, what do you know? We get x squared plus x times x equals 6. Now, if you guys can see, I just substituted the y in for the x. So this one was a little bit different, the way I went about it. Either way is going to be fine. 4y squared plus 2y squared equals 6. 6y squared equals 6. Y squared equals 1. So y equals plus or minus 1. So that means I have a point with 1 as y and a point with negative 1 as y. Okay. Now you're going to have to plug back into the other equation to get the x value. Okay. When you do that, we find that the x value will equal 2 and negative 2. Okay. Now, you can check both those, and those are fine there. Here, we have 2x squared, right? One here and one here, equals 6. X squared equals 3. So x equals plus or minus the square root of 3. So we have a point with square root of 3. And we have one with negative square root of 3. Okay, when we plug that down below here, we get that y is square root of 3, y is negative square root of 3. Ta-da! Okay, that was just as a review on how to solve things algebraically. There is no homework to this, so you may go on to the next one or take a break.